In this video, I'm going to talk about the gel effect, also known as the Trommsdorff-Norrish effect. To understand this effect, we first need to briefly cover what free radical polymerization is. Free radical polymerization, like all radical reactions, can be divided into three distinct steps: initiation, propagation, and termination. In the initiation step, a molecule is cleaved to give two radicals. The molecule that is cleaved is called the initiator, and is denoted by the letter I, and the radical is denoted by the letter R. This process can happen through a number of different mechanisms, such as thermal decomposition and photolysis. The radical can then undergo a radical addition reaction with a monomer. In free radical polymerization, the monomer contains a vinyl group. This creates a new radical, called a chain carrier, here denoted by Rm. Both of these reactions make up the initiation step. In the propagation step, additional monomers can add to the chain carrier through radical addition reactions. This creates the growing chain carrier. Here, M subscript N represents the growing chain carrier, where N represents the fact that there are many monomers in the chain. Monomers can continue to be added along the growing chain carrier until termination. In the termination step, the growing chain carrier can react with a radical to create a stable molecule. Termination can happen in several different ways. For example, a radical that was formed from the initiator may react with the active chain end, or two active chain ends may react together to create a larger polymer. This latter reaction is the most significant and plays an important part in the gel effect. So what is the gel effect? The gel effect is when the rate of propagation accelerates near the end of the reaction. This initially doesn't make much sense, because over the course of the reaction, monomers get used up, and therefore the concentration of monomers decreases, which should decrease the rate of the propagation reaction. However, the rate actually speeds up. This happens because the polymer chains also get longer as the reaction proceeds. This increases the viscosity of the substance. This increase in viscosity has important implications for the termination reaction, where two active chain ends couple together. This termination reaction is diffusion controlled, meaning that the rate of the reaction depends upon the ability for the two active chain ends to find each other, rather than the energy barrier required for them to react. This is due to a low activation energy. So, as viscosity increases, the ability for these growing chain radicals to diffuse decreases, and so the rate of termination decreases. This means, assuming that there are abundant initiator molecules and monomers present, that the concentration of the growing radical chains will gradually increase. This means that more propagation reactions will occur, resulting in an increased rate. These propagation reactions are exothermic, meaning that more heat will also be released. This increases the rate at which the initiator molecules will cleave, which increases the rate of formation of the chain carriers, and hence will further increase the rate of propagation. This further increases the heat released, and this cycle can continue. An explosion may occur if there is nothing to capture all the heat that is released.